Assalamualaikum and very good day to the examiner. My name is Muhammad Saifullah and I would like to present my research project. The title is the optimization of the torrefaction parameters of the Malaysian bamboo pellets. The torrefaction is a pre-treatment of the process that alter the chemical and the physical properties of the biomass. In this research, Malaysian bamboo pellets are being selected as a raw material. Now, let's go for the objective. The objective of the research is to study the optimum torrefaction process parameters of the Malaysian bamboo pellets via response surface methodology. There are three problem statements, which are the lack of study that has been done on the properties of the Malaysian bamboo pellet at the present. The second one is the biomass industry is still not recognized as a major source of the energy. And the last one is to produce the torrefied bamboo pellets that effectively as a potential fuel. The optimization of the process parameter for the torrefaction is needed. Now, let's talk about the scope of the research. The scopes are the Malaysian bamboo pellets that be supplied from the mine bamboo Seram Berhad. The second one is the technology of the torrefaction. The third one is the experimental method by using the split tube furnace. The fourth, the optimization of the parameters conducted by using the design expert version 11 trial software. And the last one is the optimization of the responses consists of the mass yield, energy yield, and the calorific value. There are 5 main parts of the methodology. Part 1 is the material preparation. Part 2 is the drying process. The raw bamboo pellets that get from the mine bamboo Seram Berhad being dried at 105 degrees C using the oven for the 24 hours. The next part is the torrefaction process. This process was performed by using the split tube furnace in an inert condition. The parameters used are the temperature between the 200 degrees C and until the 300 degrees C, while for the holding time between the 30 minutes to the 60 minutes. The next part is the property analysis. This analysis is being done by using the equation and the linear correlation model from the previous studies. And the last one is the optimization part. This part had been done via the response surface methodology by using the design expert software version 11 trial software to generate the optimal condition for the parameters. As you can see at the table number 1, it shows that the data for the every responses after the torrefaction processes. For the result, the mass yield of the bamboo pellets is decreasing due to the temperature of the torrefaction increasing. This is because of the decomposition of the bamboo pellets, such as the moisture content and the hemicellulose turn into the volatile matter. While for the HHV for the torrefied bamboo pellets show the increasing trend when the temperature increasing. This is because the large amount of lignin in the torrefied biomass does result in higher HHV. The mass loss and the HHV value of the torrefied bamboo pellets are highly dependent on the torrefaction temperature. The mass loss for the torrefied bamboo pellets at 300 degrees C and 60 minutes is 49.85%, which is much higher compared to the temperature of the 200 degrees C and the 30 minutes, which is only 2.2%. It is shown that the drastic increase in the mass loss is due to the increasing in the temperature. Thank you. Is the holding time also slightly affected the mass loss of the torrefied bamboo pellets. For example, the mass loss for the bamboo pellets at 200 degrees C and 30 minutes was only 2.2%, while the holding time of the 60 minutes was 3.08%, which shows only a slight increasing in the mass loss. Besides that, holding time also increased significantly the HHV compared to the temperature that increased much higher for the HHV. Now, let's go for the ANOVA analysis. The F value of the model for mass yield is 43.96, HCV is 43.82, while the energy yield is 48.78. This F value implies that this model are significant and there is only 0.01% chances that the model F value this large could occur due to noise, while for the P value is less than 0.05. For these three models shows that the model is very significant. The value of correlation coefficient R square for the mass yield, HSV, and the energy is 0.93, 0.9359, and 0.9421 respectively, proving that the value are reasonable. Next is the model acceptability. Can be checked by the lack of fit check. There is chances of 0.7%, 0.69, and 0.34% respectively for the mass yield, HSV, and the energy yield model of terrified bamboo pellets that lack of fit value could occur due to noise. Thank you. Figure 1, Figure 2, and Figure 3 shows the response surface graph for the three responses. Figure 1 shows that the mass yield decreased from the 97.8% to the 50% for the temperature range of 200 degrees C to the 300 degrees C. This is due to the decomposition of the terrified bamboo pellets. Figure 2 shows that the calorific value increased from the 60.86 mJ per kg to 23.29 mJ per kg for the temperature range of the 200 degrees C to the 300 degrees C. This is because of the changes in the role of the hollow cellulose to lignin when the temperature of torrefaction increase. Figure 3 shows that the energy yield decreased from the 92.54% to the 65.55%. This is because the energy yield is correlated to the mass yield. The mass loss during the torrefaction phase has a beneficial impact on the holding time to provide more space for the oxygenated volatile to develop. Thank you. Now, let's jump to the determination of the optimum condition. Table 5 shows the predicted and experimental value of the responses at the optimum condition. As you can observe from Table 5, there is 5 generated solution that has been suggested by the software with the same value of the desirability. In this case, number 1 was been selected with the optimum condition at the temperature of 241.7 degrees C with a holding time of the 60 minutes. As for a conclusion, temperature provide more influence on the calorific value than the holding time. For the ANOVA analysis, correlation value for each model indicated that the model is a good fit to experimental data, while for the lack of fit test shows the lower percentage for each model. Now for the recommendation part. The validation of this generated solution from the design XP11 need to be verified by conducting the experiment under the optimized condition. Next is a study of the torrefaction effect on the hydrophobic property of the raw and the torrefied Malaysian bamboo pellets. Last but not least, I want to express my thanks to my advisors, Dr. Shamila and the Madam Fariza Hamidun, for their support and guidance. Thank you.